afternoon, and thanks for joining us. I'm Keith Silva, in for Judy Simpson. The saying goes, if you build it, they will come. For the last 5 years, Vermont has seen a boom in businesses connected to food. From farmers markets to local foods to value-added products, food is big business for small farms. One roadblock these entrepreneurs face is that small-scale agriculture doesn't always fit with systems built for bigger markets. So in 2012, University of Vermont hired an agricultural engineer who could design, build, and right-size equipment for Vermont-sized farms. Joining me is UVM Extension's agricultural engineer, Chris Callahan. Good to see you, Chris.
Good to see you too, Keith. Thanks for having me.
Chris, what were some of the issues that were going on when you started?
Well, in 2012, we were just coming off of two sort of historic price peaks, one in fuel and one in feed. And both of those, of course, affect Vermont agriculture very much. So a lot of the pain that farmers were feeling had to do with the costs of fueling tractors, heating greenhouses, feeding animals, etc. So those were some of the key issues I was facing with Vermont's farmers.
How hard is it to get equipment for small-scale agriculture?
So small scale is one part of it, but also Vermont or New England or Northeast appropriate is another part of
Okay.
it. So it's not always about the scale of the operation or the equipment, but also just the appropriateness of it. And it can be very challenging. There are certainly options out there. The two challenges we often face when I'm working with farms is the cost of that equipment and also the uncertainty associated with it. Will it work for my operation?
Okay.
And so working through that in a real careful way.
Well, storing crops like carrots and potatoes helps vegetable growers turn a seasonal business into a year-round operation. The challenge can be able to monitor those crops for temperature and humidity. Here's Pete Johnson of Pete's Greens talking about how Chris helped him stay on temperature.
This storage thing has really helped us to make a well-rounded year-round business where we have quality managerial staff that stays year after year and has really taken a lot of the crazy ebbs and flows out of vegetable farming in a climate like this.
For these vegetables to stay fresh for over 6 months, the temperature and humidity have to remain constant. Half a degree too high or too low means at least a week less of storage time. In Vermont, Pete's Greens may be a major player in the marketplace when it comes to selling storage crops. But outside the Northeast, storage facilities can be several acres in size, making Pete's facility minuscule by comparison. So installing a proper monitoring system is much easier said than done.
This is the kind of stuff where you go online, you check out what, big storage facilities, they have a certain kind of monitoring system, blah, 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 and you contact that company. And you're just not speaking the same language. It's a very different, they're dealing with, acres of storages where people are spending maybe $250,000 to set up the proper monitoring and all this kind of stuff. And it's very different to be able to call up somebody and say, hey, I want the second smallest model of what you have because it's perfect for me. And to call up with somebody and say, hey, I need something 10 times smaller than what you have. And that'll be perfect for me. And they're going to say, I have no idea what you're talking about. I don't know 10 times smaller.
So what these are little thermistors. They come from the medical industry. They're using catheters.
To find a right-sized monitoring system for his business, Johnson contacted Chris Callahan, an agricultural engineer with the University of Vermont Extension. Callahan's solution was to do what engineers do best.
We needed to build this simply because it didn't exist at a price point that made sense for our growers and frankly any small to medium-sized grower throughout the country and the world.
Each thermometer connects to a microprocessor that transmits information over the internet. Johnson and his staff can then monitor temperature and humidity readings from anywhere using either a computer or a web-enabled device like a smartphone.
It's a continual process of identifying a need, having a conversation about what might work, giving it a shot, with the understanding that it's an on-farm research project and learning along the way.
If you're just joining us, I'm talking with Chris Callahan, agricultural engineer for UVM Extension. Chris, what are you still learning when it comes to this project?
This project was really interesting for me. I figured it'd be a simple matter of getting some monitoring equipment in the coolers and give farmers visibility into temperature and humidity.
Right.
How much could there be to it? The temperature aspect of it was pretty well in hand. But the one thing that we learned was humidity measurement and control is a real challenge, and that was a bit surprising. The other thing that we continue to learn is just how much benefit there is to good control of conditions. Temperature and humidity conditions in storage can have a very dramatic impact on product quality and therefore profitability of the business.
Right, and just waste. I mean, if it's no good, they have to throw it out.
That's right.
It doesn't work at all.
Yeah. The other thing is it's easy to fall into this sense that we have internet everywhere, and of course for anything involving data, we need internet to really get at it. And it's not everywhere, it turns out.
It turns out. Well, the project at Feats Greens involved microprocessors and humidity sensors. Another project that Chris has helped farmers with was how to heat greenhouses at a low cost and lessen agriculture's footprint. Here's Dave Marchant of Riverberry Farm in Fairfax.
We're really trying to reduce our propane use, mainly because one, a cost, and two, in terms of climate change and our carbon footprint, using renewable fuels makes a lot more sense. And it's great because the wood pellet industry is a real local industry now. It's all within just the Northeast. So.
One catch to this project is that most of the commercially available biomass boilers are not set up for small fruit and vegetable production. So Marchant has been working with University of Vermont Extension to help him through his growing pains.
The great thing about this project with Extension is that they've allowed us to kind of experiment with some systems and realizing that it takes quite a number of years to figure out what's going to work well with the greenhouses. This unit has worked quite well. I think we're learning, and the Extension program allows us to experiment. And without that, funding-wise, it would be really difficult to put the money out ourselves for that.
We installed a number of different ways of getting heat into the greenhouse. We've got a lot of options added to this system that ultimately an installation wouldn't have. So we're trying to demonstrate not only switching to a different fuel, a renewable, relatively carbon neutral fuel, but also different ways of getting the heat into the crop. Either through heating the air, heating the ground near the actual roots of the tomatoes, for example. Heating crops that are grown on benches with hot water flowing through them. The other thing that happens when you move away from a hot air furnace to a boiler is you're moving water as opposed to air. And so there's more plumbing and pumps and valves. And so some of that can be difficult to sort out without a little bit of help. So my role to a large extent has been designing that system and helping figure out the pump sizes, the plumbing sizes, and how it all works together.
That way. It hasn't been an issue with two houses because it takes everything that it's got. Having an extension engineer really helped me in terms of trying to design the system. Extension was extremely helpful in this whole project.
Well, getting these biomass boilers set up was one of your first projects. What's the impact been since you started on the project? And what happens when it comes to the environment? What's the impact there?
Right, so these biomass heating systems ultimately reduce the use of fossil fuels. And so we're moving from fossil fuels to biomass fuels, and that reduces the overall net carbon footprint of the operations of the farms. So there's an environmental benefit from that. The other impact is economic, of course, and although these systems cost more upfront, there is usually a potential for fuel savings on a recurring basis. Right now, that's challenging given relatively low fuel prices.
Propane is so low.
Right. Yeah. I mean, when we first started this project, I would have never predicted propane being at or below $1 per gallon in 2016.
But the chances are that propane will go back up, and the local fuels or the biomass fuels will stay a relative stable price.
So chances are fuel prices will change.
Okay. right.
And so that's the other big part of this project is controlling that volatility. Mm-hmm. If you control the fuel, and so some of our more recent work has focused on farm sourced fuels, not just biomass. But not just wood pellets, for example, but farm-sourced fuels where you can actually have much better control over the costs of the fuel.
Well, in the last few years, craft brewed beer has become synonymous with Vermont as ice cream, cheese, and maple syrup. To top off their beers, brewers wanted locally grown hops, which is easier said than done. Here's hop grower Nick Alaria.
Well, the first year we picked by hand I got a party of about 10 people up here, and we had a bunch of homebrew and barbecue, and we just sat on a picnic table up there and picked all weekend long, and it took a long time.
If you think picking apples is a daunting task, imagine picking hops. You know, it's just, they never seem to end, and it takes forever to get even a pound.
Matt Nadeau shares the pain of being a small-scale hop farmer with Alaria. Nadeau is the owner and brewmaster at Rock Art Brewery in Morrisville. He has a small hop yard at his own home and enlists his family to help with the harvest.
And we just pick and pick and pick till you're just tired of it, and then we call it good.
There are machines that can separate the cones from the bines, but they're expensive and mostly used by large commercial hops growers in the Pacific Northwest. For small-scale growers like Alaria, there was simply no other choice than to harvest by hand. Until now. This new one-of-a-kind machine, developed by the University of Vermont Extension, is changing that.
We're seeing a much greater demand for locally grown hops to support a booming microbrew and craft brew industry in Vermont and in New England in general.
Tell me about the day that came with the harvester.
Oh, it was awesome. That was Labor Day. He came out to our farm. My father and I had cut all the plants off of the trellis the day before. We brought them into the barn. Chris came the next morning, pulled right up to the barn, and we just started firing bines through the machine, and hop cones were flying off every direction. It was quite a sight to behold.
What if they hadn't come?
I probably would be insane right now, and I probably wouldn't be done picking hops either.
It is still a very labor-intensive process. We've taken it from something that takes an hour per bine to something that takes a minute or less per bine.
Well, in a minute, we'll let you know how you can download some engineering plans of the hops harvester that Chris designed, so you can build your own small-scale hops harvester. Now, when we started working together, Chris, this was the thing. Like, we were like, we got to talk to the hop harvester guy who built it. What are some of the challenges that you're facing this year and in the few coming years?
Well, there are always new crops being explored by Vermont's farmers, and so there's always something new coming along. Hemp is a new crop being explored, for example. So we're looking into what that means after it's grown and harvested. Okay. So that's those new crops always present new challenges. The other thing is I'm seeing increased integration of both production and processing. So value added products from Vermont-grown raw materials, and so that introduces some new needs that some folks aren't very familiar with. Yeah. So the other area where there's, I think, going to be a lot more work is in increasing labor efficiency, and this isn't just about farm staff. That's a big part of it, but also about owner-operator efficiency and just quality of life. And there's this project Deb Haliba is leading up related to social sustainability. And how do we ensure that today's farmers will be there tomorrow? So looking at some of those issues. We got just a little bit over a minute left, but there's one thing we talked about before we started. You said you're working on robotic weeders. Really quick, Chris, what's a robotic weeder? Right, so there's a number of different kinds of robotic weeders. The project we're looking at, Heather Darby and myself with partners from University of Maine, is a band sowing implement. It's on the back of a tractor, and instead of planting grains in individual rows, they get planted in bands, so higher density bands that are further apart, and it allows us to come back and cultivate in between those for organic grains. But that needs some robotic guidance. So I think there's more to be done there. Well, Chris, how can viewers get in touch with you? Best way is through the website uvm.edu, extension/agriculture, and then there's a link for engineering. Excellent, excellent. Well, Chris, thank you very much. It was good to have you here and to see you again. I want to thank everyone here at WCX for making this program possible. And as always, thank you for stopping by Across the Fence.